Hi guys, I welcome you to my channel. Today I'll be solving this word search in the binary in backtracking problem. Combine some combination some was like I was not able to understand how it works, how behind the scene work it works. But code is very simple, but I was not able to understand. That's why I will not solving this problem today. I hope I can solve it tomorrow. So this is word search, and what does word search do? Let's see. I'll be given a m cross n grid. This is a grid, and a string word return true if word exists in the grid. So if word exists a b c c e d word exists here, so I have to return true, otherwise return false. The word can be constructed from letter of sequentially adjacent cell. So he's saying that you have to take sequentially adjacent cell, not any random cell, where adjacent cells are horizontally or vertically neighboring. Okay, so like he see here, A B is the horizontally neighbor of A, right? This C is horizontally neighbor of this C, right? This E is horizontally neighbor of this C, right? That is saying that the same letter may not be used more than once. So we have to track such that if we have visited this C, we can't go again this C. We have to have some types of visited keyword, visited grid, which takes the status that if we have visited or not, right? So one thing I have understood in the words uh, I understood that this is backtracking problem. How I know that? Uh, you have to find all possible solution, all possible string or word with letter A, all possible word, and the word which match with the word which match with our word A B C C D is answer. So we have to find all possible, and if they're saying that we have to find all possible combination, we have to use backtracking. That's the thing, right? Let me recreate timer. It should not take 15 minutes because I have already solved this problem. Yeah, so let's write the code for this thing. So you understand, right? We have to find all the possible combination, and if all the possible combination. So here you see, if we will loop through the grid, and if we will loop through the grid, and if we find that if that grid first character is matching with the first character of word, I will call my recursion function to check that check following characters of word right from the grid. So you see here, from one cell you can go top, left, bottom, and right. So you have to have some kind of direction as well. So if you are at one cell, you can go top, you can go right, you can go bottom, you can go left. So let's write the code first. So see what I told you. You have to have some kind of like we have to loop. We have to check all possible solution of A, right? To check all possible solution which is starting from A. So what I'll do here, I'll check first if word is not defined, not word. If word is not defined, or length of word is 0 1, not word is equal to 0. If this is the case, return but true, right? Now what I'll do here, I will loop through it for I in range of length of rows. So let me recreate a rows is equal to uh, board of length, or length of board, and calls is equal to length of board 0, right? Calls. So we will have a I from I, which is ranging from 0 to rows, and we will have calls, which will also range from 0 to calls. we will have j which is also range from 0 to calls, right? Now if our character, if character at that particular coordinate, if board of I j is equal to word of 0, if this is the case, I will call the DFS of a callback function. I will be calling, let me write this first, a callback function DFS, right? And if DFS is true, I will return true, right? If there is character, there is string, I do not have to find all possible, all the word, like all the word count. I have to find if there exists any string or any word, any string which have same character, which have same character as word. I will return true, right? That's it. Otherwise, if this is not the case, I will return false. Let me write a function called call DFS. So this will also return a boolean value. So what does this DFS takes? Right? DFS will take first thing the index of the string, sorry, word. Index of the word. So I have taken index, right? Second thing, what will take? It will take row of I, row I and call I, or I comma j. It will take I comma j. This I, this index of the particular column, right? And what next it will take? It will take the string. No, it will not take a string. Let me, I will write on the way. So these two things we have to have, right? There we have to have there. Now we have to create a, you have to get some types of some row or some types of array, 2D array that marks our board visited. So if we have already visited on the left, we have to mark them ki we have visited it. So let me create a visited board, visited 2D array, visited 2D array. How to create? We will have to a square bracket. Inside a square bracket, all the value of the 2D array will be false. So false for in range calls, okay, and then close this. Again we need a till rows, right? So again for in range rows. That is it. We have created a visited, right? That we have created a visited 2D array. Now let's check it. If index is equal to length of the word, so length of word, if this is true, we have found our string or our word, so I will return true. If this is not true, I'll check the boundary. I'll check the boundary of the, this is a base case, right? So I'll check the boundary. If we are not, are we out of bound or not? So if I greater than, I less than 0, or I greater than rows, or j less than 0, or j greater than rows, calls. If both the case is satisfied, what we'll do here, we will, okay, rows get I greater than equal to rows, not equal, just greater than, j greater than equal to calls, okay. If the both the case satisfy, I will return what? False, if we are out of bound. Otherwise we have to, one more check we have to do, that if a board of I j not equal to word of index, if both are not true, I will return false. if like the character, if the character at word index, character at index in the word is not equal to board of ij, then I will return false, correct? No? Yeah, if both the cases, all the cases are not satisfying, it means that we are not out of bound, the character are matching, right? And we have not reached the last index of the word, so all will fail here, right? So what we'll do here, we have found our character, right, which is matching to the word. So what I'll do here, I'll mark visited of I comma j as a true. We have visited it, right? One more check we have to do it, ki if not visited, if not visited, or if visited, then why we don't have to return, we don't have to visit again, so return false. If visited, we return false. We'll write, you can write here as well, or this. If visited, I will return false, otherwise I will update the visited at tree. Now what I'll do here, we have to check the 4 direction, right? We have to check the 4 direction. If we are here at f, we the character, we are at c, right? The next character can be on the right, on the left, on the top, on the bottom, anywhere it can be, right? So we have to move in 4 direction, correct? No? So we have to move in correct 4 direction. We have to have I will write a pre-decided direction. So directions will be the 2D array. First we can go to the bottom, right? That's right. So we'll update the rows value. We can go to the minus row, -1, so -1 comma 0. We can go to the right, so right 0 comma 1, and we can go to the minus right, like left side of current index, that will be the 0 comma -1 we have here, right? Now what we'll do here, we will loop here 4 indices in indices in direction. Now new I will be the I plus indices of 0, and new j will be the j plus indices of 1. So we have new I, new j, right? Just check that if dfs of index plus 1 comma new I comma new j, if this is true, I will return true, otherwise I will loop through again and again and return. If there is nothing, if we don't find anything, we return false, correct? No? So you got the point what we are calling with. We are calling dfs with index, or basically index of the word, that is 0 and I comma j. So did you understand what I tried? Let me test it again. Let me understand, otherwise I'll get syntax error. Or yesterday I had added a colon at the bottom of the statement, and I was not able to figure out what are the problem, and I spent nearly 4.5 minutes, like nearly 5 minutes to debug it. Where is the problem? So let's go through line by line. So first I'll check that not word or length of the word is 0. If the word is not defined, I will return true. The no word, I will return true, right? Let me check your test base case. What is the, at least one row will be there, okay? Now rows and word length, at least one word length will be there. So we can remove it, but let it be. We have rows and we have columns, board of I, board of 0 of columns, that we define the calls. Okay. Okay, यहाँ पे we have done mistake here. After this, we have data the visited, right? We have marked this visited as a false. So we are backtracking here. Hmm. So we have defined the rows, we have defined the columns, okay, and we have created a 2D array visited, where each cell have value false. So false for 0 in range 0 to calls, and false for rows, right? We will have a direction list. Basically, this is basically for going up, down, left, and right. This is the up, and this is for down, this is for up, this is for right, this is for left. Okay, and now index is the length of the word, means we have found our word. Okay, so if this is a true, we will return true. Now we are checking that if are we out of bound. If I less than 0, I less greater than equal to rows, or I j less than 0, or j greater than equal to columns, we are out of bound, and we return false. Now we'll check other part, key board of I not equal to word of index, means the character we are trying to review is not matching with the word of index. This means we are returning false, or we have visited already this character. If we have visited already this character, we do not have to visit again, so we will return false. Correct, no? Now we will update our in visited to false to true and false to true. Okay, and now we are looping through the directions. So for indices in direction, now we are getting new I, so I plus indices of 0, and new j, j plus indices of 1. Okay, now we are checking that if dfs of index plus 1, so we are here, right? It means that the character we are reviewing is correct, means the character we are reviewing have the same had the same character in that index. Okay, so that's why we are here. So if index plus 1 comma new I plus comma new j, if this is true, I will return true, otherwise I will update my visited of column I comma j, I will return false, and that's it. And we are looping from I to j, and trying to check if board of I j equal to word of 0. If this is true, I will return dfs of this, otherwise return false. That's it, guys. Let me submit it. Yeah, it is working now. Let me sort of. Yeah, it worked. See here, we have built. I have built 59% of the Python developer. So this was very interesting, and this is very new. Whenever I'm going down after this binary tree, it is going difficult for me because I am not. It means I have not learned more, but I will be doing. I will learning, and I will be uploading video until I get very good at these problems, because big tech company has problems from there only. Backtracking, tries, graph, advanced graph, all these things, all this stuff, right? So yeah, we have done this problem. I will be coming with the new. I will be solving two problems tomorrow, and today I have interview. So wish me luck so that I can clear that interview. And if I kill that interview, I'll definitely update here. So thanks for watching. We'll meet tomorrow. Bye bye.